problem. So maximize something which is called as your objective function. There are like 2 to 3 equations given out here, and there are also some conditions given in below. So we are technically calling it as an objective function. This is the objective that needs to be reached. Okay, maximize this, and we are just gonna maximize this function z. As I said, we are gonna maximize our throughput, maximize money with such constraints. Okay, these are your parameters given. Okay, so 10a plus 6b must be less than 2500, and all these three equations, these are called your structural constraints. This is the structure of your problem. Okay, with this structure you're gonna define what the inside properties are. So these are the structural constraints, and the third one is your non-negativity constraint that says that a and b are strictly greater than 0, or it might also be equal to 0 if there are nothing. See, practically, if you're seeing it this way, this cannot be negative. Okay, a thing cannot be negative, right? If you're having a pen, I'll have 1 pen, 2 pen, 3 pen, 4 pens, and all those things, but I can also have no pen at all, but I have to have 1 pen at least. I cannot have a negative pen, -5 pens. I can't just say about this way. Okay, so that's the reason why it's always greater than or equal to 0. Okay, so let's move on to the next slide. So we just see the solution for the problem. Introduce a slack variable to the equations to eliminate the inequalities. You could just check onto this while passing as well. So I'm just gonna be quick here, saying that there's this thing. So this, I'm gonna add slack variables. S1 and S2, S3 are the slack variables. Why 3 slack variables? The number of slack variables is equals to the number of equations. I'm having 3 equations. Okay, so I'm going to introduce 3 slack variables as such. So what is the reason to add the slack variables? Can you see the less than or equal to sign changed as the equal to sign? Okay, I'm going to put 2 plus 2 less than or equal to 6. I've given it as such. And now I'm gonna add, sorry it's too basic if you're feeling as so, but since this is 2 plus 2 less than or equal to 6, I'm gonna add something. Let me just give it as S1 itself equals 6. Now this equal to, make sure that this variable has got some value which is gonna correct this as equal to 6. Now 4 plus S1 equals 6. And S1 equals 2. So this has a value for sure, and the main objective is to find S1, S2, S3, and likewise find A and B values as well. So to solve all these things, you need to use the simplex method to make it easily solvable, as well as you arrive at the best result. Okay, so I'm gonna just move on to this simplex method. And what you're gonna do is that you're gonna just, in the first equation, can you see this equation, maximization equation? So that's my thing. Okay, I'm gonna add S1, S2, S3. Note the 0 here because there are no S1 and S2, S3. I'm supposed to add it out here because I'm gonna deal with the coefficients, so that's the reason why I'm gonna add it here. And I'm gonna just add S1, S2, S3 to a maximization function, and then I'm gonna just go on put it this way. Okay, that's the thing I'm gonna do. Bring the RHS to LHS in the max Z equation. I just put it this way. Put A equals to 0 and B equals 0 as well. When you're putting this, I could put A equals to 0 and B equals to 0 because it is A is less than or equals to 0. That was my constraint. Okay, so I'm gonna just deal with the non-negativity constraints, and when I put A equals to 0, B equals to 0, the first equation, the second equation, and the third equations becomes as such. So let me just make you refer to this. I'm gonna put a equals 0, b equals 0, so everything cancels out, and s1 equals 2500, s2 equals 2000, and s3, when put a equal to 0, b equals to 0, becomes 500. Okay, so let me just move on to the next slide. Okay, now let me this is where it is solved. I'm not gonna deal with any kind of CJs, I'm not gonna deal with any kind of all those blah 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 stuff. I'm gonna make it simple and easy for you all. Okay, now let's see the basic variables. You're gonna list the basic variables z, s1, s2, s3. I'm damn sure that this method is gonna be really easy for you all, and this could be a rare method as well. Okay, you might have not come across this method. Well, I've come across this method, so that's why I thought of sharing it to you all. Okay, so let's just move on. You're just gonna write the basic variables. What are the variables a, b, and all those things, and you're gonna write something called as the solution, where you'd write the RHS part of an equation. Okay, now the coefficients were this. Mind you that you use the coefficients of this. Okay, the z coefficients would be minus 23, minus 32, and that's how the z equations would be. Okay, so when you deal with this, I'm gonna just write the coefficients of z, and in the first equation, s1 involves the first equation, so I'm gonna put it as 10, 6, 1, 0, 0, and I'm gonna arrive at this solution. And as far as s2, the second equation, this is your thing, and the third equation by the coefficients. That's it. Now what you're gonna do is just deal with this. Okay, you're just gonna find the most negative element in this z, okay, which is 32. So I'm gonna just check mark the column of this one. I'm not gonna check mark the row because I've already scanned through this row and I've found the most negative element. So I'm gonna mark the column here. And when I mark the column here, I'm gonna just divide the solution with the corresponding selected values. Okay, so in this washout, this 6 and 2500. So I'm gonna divide 2500 with 6. That's why I've included the other column called ratio, where I would have done all these things. And I'm gonna divide this 2000 with 10 and divide 500 with 2. Okay, so when I do that, this is my answer. So as I said, 2500 is divided by 6 and you get this answer, and 2000 is divided with 10 to get this answer, and 500 is divided with 2 to get this answer. Now you're gonna find the least positive element, which is this value. 416 is greater, 200 is okay, check it out, and 250 is greater than 200. So let me just mark out this row, and that's how you get it. Now can you see an intersecting value, and that's 10. So this is called as your pivot element. Okay, now what you're gonna do is, in the next step, you're just gonna divide the corresponding element with the pivot value. Note that we have also changed this b values. Okay, since I'll tell you why you're just doing it this way. See, I have marked this column. Okay, I've marked this column and this row. Okay, I've only got two values, which is a and b. There is no s1 or s2 or s3 values. The slack variables are introduced by me, and that's the reason I'm gonna replace b with this one, s2. So that's the reason why I've replaced this b with this here. Okay, so let me just move on to the formula. Element divided by my pivot value, which seems to be this one. 10 was my pivot value, and I divide every element with respect to 10. Okay, so when I do that, I get an answer, and that's how I do it. This is gonna be the second iteration, and this is gonna be replaced as b. Okay, now there's a formula for the other rows, so you could solve the same in this way. But what about the other values? This is gonna be your iteration 2. For the other values, you're gonna just move on to the next one, which you're gonna apply the formula current row minus pivot column element into new pivot row. Your new pivot row is the row that you've found right now. Remember that in the previous step I did what I did, and your pivot column element is something that deals with B. The checkmarked column is your pivot column element, where the pivot element lies. Which column does the pivot element rise? And your current row is what you're gonna find for. If you're using this for the Z row, then this is your value. If you're using it for S1, if you're gonna find the values of the S1 row, this would be your current row, and for S3 the corresponding current row values would be replaced. So the calculation is involved here. Now this is your current row. Just look at it this way, okay? Your old Z value. What was your old Z value? That is actually your current row. You're solving it for the current thing. So this old Z value, and this is your pivot column value. Let me just tell what the pivot column value is. That the pivot element is this, and this value is for Z, and this value you'll be replacing for S1. So when you're gonna find this for S1, 6 would come as such. So when the calculation is for S1, 6 would come, and when the calculation is for S3, the same corresponding pivot column element value would come. The S3 value is 2, so 2 would be replaced in case of minus 32, where I've done the calculation of that. Okay, so for S2 and S3, all those things would come. So this is your pivot column value, and the next one is your B value, which you have just found out, dividing by 10. So I've already substituted such values. Kind advice is not to use decimal here. Only in the last step, when you find all the Z values to be positive, you're supposed to make it. Okay, so now you're gonna just move on to this, and similarly we calculate the values for S1 and S3 as well, noting that the pivot column value is also changed here. Okay, so now this involves the iteration 2. Now after solving for Z, the corresponding values, can you see these values? You'd be replacing these values to the next one. Okay, all these values, you're gonna replace all these values here. Okay, so when you're gonna replace all this, you'd be getting this. As I said, do not replace this as your decimal value, whereas in the case of solution you have to, because you need to find which one is greater and which one is smaller. So I'm gonna write all the values. Note that in S1 we are also solving it for solution, whereas in Z I solved it only till S3. Okay, so now I'm gonna use the other thing. For B I just found out, and for S3 I just found out. Now let me move on. Again, repeat the first step. Find the most negative element here, which is minus 7. Well, until what are we supposed to do? The iteration is that we are only supposed to do this until you get all the Z values to be positive. Okay, now we are gonna just divide 7 and 1300, and 1 by 2 with 200, and 0 with 100, and when we are gonna do this, we get this answer. And now when we find the answer, we are gonna get, note that we are getting an infinite number out here. The reason is because we are only involving the least positive element, and so we are not really bothered with infinity. So you might all be wondering, oh no, there's an infinity over here, and should I deal with lemma and all those things, limits and all those things, continuities? You are not gonna deal all these things here. So we are just gonna involve this one, the most negative element and your least positive element. You get the pivot value as 7. Repeat the process. Okay, pivot value is 7. Repeat the process. can you see this? Okay, can you just see this? I just got the A value, so I'm gonna replace this as A. Okay, you have to see this, replace the values here. I'm gonna replace it here. Okay, so after doing this, this becomes my new pivot row. Okay, so I'm gonna do this calculation again. You may pause the video and see it as such as well. Current row minus pivot column element into new pivot row. Note that I've also done it for the solution as well. B, don't worry, B is your value for S2. Okay, so this is gonna be replaced as such. Okay, so this is your solution. Also divide your solution with the previous one, don't worry about it, and you just got your answer. Okay, so you're gonna replace this as your solution as well. So here when you see, you replace the solution here as well. So this is your answer. Now you see that there are no negative values in Z. Okay, let me just highlight this. There are no negative values in Z. Okay, so when you see that there are no negative values in Z, you may stop as such. And can you note, I've also added decimal values here, because as I was just calculating everything in the Z values, you noted, can you note this? I've also included decimal here. What I said in the previous was not to use decimal. Why did I use the decimal here? It's because as I solved these Z values, I came to know that there are no negative numbers out here, and I knew that I'm gonna stop with the third iteration itself. So I had to take this as this value so that it'll be easy for me to get the solution. Well, you may also write it in the case of decimals as well, but I didn't want to, so I could just take it this way. This looks plausible, and there are no negative values in Z, and so you could just stop the iteration. And now how do I find the solution? Well, you've got a matrix out here. The value of A is 185.7 and the value of B is 107.14. Can you now note why I was actually replacing the values of S1 and S2 as A and B? So this is the reason I need to get a solution here. That's the reason why we have replaced it in the previous step. Okay, so let me move on to the next one. I'm going to substitute this A and B values to our max Z equation. And when I'm going to substitute the values, I'll be getting this value, which is also rounded off to 7,700, and the answer is 7,700, where A equals 185.7 and B equals this value. Okay, and that's how you try to put it this way. You could also substitute it by checking as well. Substitute the A and B values, and when you're gonna substitute all these things, you get the answer which is less than or equals your RHS value. And when you're gonna do this, you're also gonna get the same thing, and when you're gonna do this, you're gonna check the same thing. Okay, so you could just check it this way. Thank you all.